this training module, we will go through the details of the processing report included with each survey. This report is created for each dataset uploaded to the platform. The processing report provides an analysis of photos and how well they align. Additionally, the processing report details a quantification of how well the model fits with the uploaded ground control points. The processing report is divided into 5 sections: the dataset details, an overview map, and a graph of image quality, a table of expected ground control accuracy, and a ground control summary table. We will discuss all these sections in greater detail. Welcome to Propeller U. Processing Report Overview. To access the processing report for the survey you are currently viewing, click on the reports in the top right corner and then click the Processing Report in the drop-down menu. Your report will open in a new browser tab. The processing report details various aspects related to your data set, including but not limited to the filters used, the image quality, and the accuracy of ground control points. In the top right corner of the processing report, you can click on the Print button. This will allow you to print a hard copy of your report or save the report in a digital form. The processing report will always be available online with your survey. The first section of the processing report provides details of the dataset, such as dataset name, horizontal and vertical coordinate reference systems, geotag accuracy, and the number of source photos. If the arrow points were used for ground control, you can click on the name of the arrow point survey to open up the details page in a new tab. This is a detailed report of the arrow point survey that was used to process the dataset. The processed location of the arrow points is visible through this link. If you have additional questions about the arrow point survey details, please contact your customer success engineer. The second section of the processing report includes an overview map showing a base map, the ortho photo of the processed dataset, and the location of your ground control points. A legend of the overview map is located below the map. To zoom in and out of the overview map, you will first need to click on the map. You can toggle the dataset features on and off. Turn on the filter difference to display the extent and magnitude of the filter used in the processing. When you're looking at the filter difference, a legend will appear in the bottom right hand of the map. When the photo layer is selected, good images will be displayed as a green dot, poor images will be displayed as an orange dot, and unaligned images will be displayed as an X. In a moment, we'll explain what good, poor, and unaligned images mean. The next section of the processing report provides information regarding image quality. This is primarily communicated through an image quality plot, where the quality of the image is given a value between 0 and 1. The image quality value is determined by multiple factors, but can be simplified to represent how sharp the image is and how well the image can be used for photogrammetry. Any photo with a value greater than 0.8 is deemed good, while a photo with a value less than 0.8 is deemed to be poor. Images with a quality as low as 0.4 can still be used to generate the final model. An unaligned image is generally too poor quality to be used for photogrammetry. Common reasons for low quality images include excess motion blur or poor exposure. Below the image quality plot is a table that details the total number of photos, including the number of good, poor, and unaligned images. A second table provides the X, Y, XY, Z, and total error for the photos. This table details how much the images were shifted from their original geotag location during the processing to best fit with the provided ground control points. If you have questions regarding error values that are greater than expected for your drone, please contact your customer success engineer. The next section of the processing report covers expected ground control accuracy. This details the difference between the positions of the modeled and uploaded coordinates for ground control points. Within the table, the X, Y, Z, and total error is provided for each ground control point. The total error is the distance in 3D space between the modeled location and the uploaded location for the ground control points. For the final model with high accuracy, the goal is to have the total error values less than 1/10 of a foot or 3 centimeters. If you see a ground control point or points with a total error value greater than 1/10 of a foot or 3 centimeters, please contact your customer success engineer who can help you to investigate if this is an issue that needs to be addressed. The next portion of the processing report is the ground control summary. This table shows the vertical difference between the uploaded ground control points and the final model. The table provides the easting, northing, and elevation for the ground control points that were used to generate the model. The surface elevation is the modeled elevation for the same easting and northing point as the ground control point. The difference between the surface elevation and the elevation is provided. This is the difference between the provided Z value for the ground control point and the modeled Z value. The goal is for the root mean square of these values to be 1/10 of a foot or 3 centimeters or less. If you see the total error value greater than 1/10 of a foot or 3 centimeters, please contact your customer success engineer to determine if this is an issue that needs further investigation. If you included checkpoints with your data during the data upload process, there will be an additional table below the ground control summary table showing the vertical differences between the uploaded checkpoints and the final model. In this module, we learned about processing reports and how to interpret the information in each section. Thanks for watching. If you have any further questions regarding your processing report, please contact your customer success engineer or check out our knowledge base, help.propelleraero.com.